All right, good morning, everybody. Welcome to a beautiful morning and an exciting morning of chemistry with your host, Dr. White. I'll only ask you once or twice more. Clicking is gone. Victory. For those who don't know, Winston Churchill in World War II used to go around like that, V for victory. That's when London, unfortunately, was being bombed by the Germans.
How did you fix the clicking? You were struggling so much the past couple of times.
Let me, we got time. You're here till midnight. No, but anyways, uh, what happened was my I used Sabrent and I have for years uh, for a USB hub with switches on them. They're nice, except the wire is thin and they go after a while. Well, yesterday, what was it? In this class or the other class, it started to go. I think it was this class. And I realized, yeah, I'm tired of buying these. What's the better one? So I looked on Amazon, where else, if you need something quick. And I was saying, what's better? And all of a sudden, I see a powered USB where you have a separate connection to power it up. And I'm thinking, oh my gosh. Actually, I said something a little more stronger, but I won't do that in my class. And I said, am I pulling too much power that the Sabrent, which is going directly to a USB port, can't? I looked up a USB port three can, you can pull 900 milliamps for those of you who don't electronics. It's been a hobby of mine since high school, so I know that stuff and I should have known better. I realized with my web camera, my tablet, and my mouse on there, I was right at the limit. My old camera probably had a smaller energy draw, and the newer Logitech, which you're seeing me in living color, uh, I just did a generation gap thing on you people. Uh, Probably pulled more energy, and I was right at the limit of how much it could supply, and the camera was being starved for energy, and that's probably why it made that clicking noise. It was saying to me, I'm not happy. And I just didn't realize that. When I thought that, I said, let me try a powered one. And hold on, let's do something. I'm going to be doing something this morning different. That's not what I wanted. You can see the powered USB. And this right here is power. This goes to my computer, and I got a lot of wires. I got a lot of stuff. But anyways, that's how I did it. All right, let's get started. All right, today, here's the game plan. One, I'm going to teach you how to use this. Two, I will, and for those who already know how to use it, I'll just review stuff. It'll only take a little while. Next, I'll go through the problem set number two. And finally, I will show you the key things about and go through the density lab. And what I call my setup or introduction is like what I would do if we were face to face. The only difference is because we're using Beyond Lab Z, I'll show you how to do the different operations. If we were in a lab, I'd show you how to use the actual glassware and other equipment. So let's get started. What happens if you have to, and let me get a whiteboard up. What if you had to multiply these two numbers? What do? Well, I can do that in my head because I learned on a slide rule. maybe next week I'll bring my slide rule up here. It's downstairs in my living room in a position of honor. But how do you do that on a calculator? Let's find out. Now, if you notice, both are in scientific notation. How do you put that into a calculator? Well, let's go try this. Let's see how well this works. Oh, by the way, I'm never going to be a hand model on TV. All right. For those of you, hopefully you don't get motion sickness. All right, here's my calculator. And can you see it normally? Like it's not up, I'm seeing it up backwards. But anyways, I'm going to turn it on. I'm going to clear it. And if you look right here, there are different things. And one of them you can see says SCI. Now, how do you get that? If you look here, you have a blue button, and then that's the second key. And right here, notice where it says SCI. If you push that, you'll now see on the screen three things. On mine, it's FOL, floating, SCI, scientific, ENG, engineering, which I've never used. And your arrow keys allow you to adjust it. For scientific notation, you want SCI, there, that's better. And then you hit enter, and now you're in there. I should use my other camera, but anyways. Now, how do you do your numbers? Well, the first number is 2.0, so I'm going to just put in 2.0. And there it is. How do you make that 2.0 times 10 to the fifth? Well, you need scientific notation. And on here, you have the blue key, second key, and then right above for this calculator, x to the -1, there's a double E. I should have gone and gotten my nails manicured. Don't look. And now see how there's the letter E. That's like 10 to the power. And if I want 5, I put 5. So that's 2.0 times 10 to the fifth. Next, it's multiplication. So I'll use the X on the side here. And you see a little star. Next one, I want 3.0. And now, once again, blue key, the second key. Then come down here. Come on, focus. You do double E. And again, you see the E. I'll do 6. And then I'll hit enter. And right here, you'll see, oh, I did 5. Hold on. Let's do it again. I put in the wrong numbers because I was watching my camera. Now I've got it right. If you look over here, you see 6, and then very tiny times 10x times x, and then 10, and then a big 11. There you go. and that's 6 times 10 to the 11th. Now, you have to use proper scientific notation, and the first 2.0 and 3.0 are two significant figures, so you put down 6.0. So that's how you do it. Now, let's do another one, and this is very important, so pay attention. And let's try 3.5 times 10 to the fourth times 5.3 times 10 to the minus 2. Well, the first part you already learned how to put in. Let me clear. Don't forget each new problem clear. I'll put in 3.5, then I'll do second key, double E, 5, X, and now we have 5.3, blue key, double E. Now, you want to put in minus 2. You do not use this number right here, this key, minus. You don't. That's for subtraction. Let me do it this way. That's for, oh, it looks professional now. That's for subtraction. What you use is the minus in the bracket. Your calculator might be different, but somewhere on the keypad, you'll see bracket minus close bracket. That's for minus 10 to the minus power. Again, use this key when you're doing minus 10 to the minus, not this key. It's a common mistake students make, so I'll say it again. When you're doing minus power, use this key. Don't use this key, use this one. And if you see, I'll put minus, see the minus at this, and I want minus 2, and I'll multiply it. And my calculator gives me 1.855 times 10 to the fourth. Now, both numbers were significant, two significant figures, so you've got to round that off to two significant figures. I'll let you try, round off 1.822 to two significant figures. Go. I'm gonna sneak in some tea. And the answer is 1.8. Keep the 1, keep the 8. Oh, wait, it's 1. I'm looking at mine. My screen is backwards. It's 1.855. I'm sorry. Round that off to three significant things. That'll teach me to look at my screen. By the way, if you ever wondered what I see when I'm looking at you, it's that. And then above, I have little stuff in my big speakers. There's one of them, there's the other. And that's why I don't need hearing aids. But anyways, 1.855, round off, keep the 1, keep the 8. Number 5, is that 4 or higher? Yes, it is. So drop the 2 5s, and that should be 1.9 times 10 to the fourth. All right, let's try one more, and I'm going to let you do yours if you have your calculator. If not, you can just watch me. Let's do one more. And why don't you try that? This is a division. And use the key with the dot, line, dot below. I see someone had a question. Go for it.
Are we going to be able to use calculators on the test, or should we figure out how to?
No, you're going to be using a calculator.
Oh, okay.
That's
Thank
what I'm
you.
showing you how to. First of all, that's a great question. I'm glad you asked it. And as you know, all questions are great ones, but that's why I'm showing you. Uh, your phone ain't going to hack it, and you shouldn't be using your phone to begin with. But that's why I'm showing you how to do this. All right, let's go through and do it. First of all, clear it. I want, what did I have? Hold on one sec. All right. Let's take a look. We want 4.6. Now, blue, the second key, then the double E, that's above right here, you push to get the power. Then you want to use the minus sign here, and that's -2. Then it's divided. You'll do this. And then we want 8.1. Then again, blue, double E, and again, minus right here, not this one, and we have 8. Hit enter, and notice the number my calculator just spit out at me. That's a lot of significant figures, and that would be 5.67901234 times 10 to the 5th, and you'd round that off to 2 significant figures, which would be 5.7 times 10 to the 5th. Let me do one thing real quick. Hang in there. You can watch my keyboard and everything. All right, what I'm doing, 2.0 times 10 to the minus 3 divided by 2.0 times 10 to the minus 10th. I've done that. That's not what I wanted. Hold on. All right, now I'm doing it right. I have 2.0 times 10 to the minus 2 divided by 2.0 times 10 to the 10th. And what I wanted to show you is, and sometimes students miss it. See right here, there's a minus sign. That means minus 12. That little minus sign right there tells you 10 to the minus 12. And that's how you use your calculator. And I'm back. Now, if you have any problems using your calculator, hold on while I put the webcam back up where it should be. I have 2 webcams. This is an HP older one. Luckily I had when we switched. Whoa. Stay. No, it doesn't want to stay. There. But anyways, practice with your calculator. Like everything I've taught you, practice makes perfect. Don't take the exam and you haven't practiced it. Try some of your own problems. If you're having difficulties with the calculator you have, and it wasn't the Texas TI 30XIIS solar powered, so you don't have to worry about it. I'm going to shut it off now. I've had this a number of years and I haven't changed the batteries a long time. But anyways, if you have a different one, you can't figure it out, come to my office hour. I've yet to find a calculator that's been made in the last 10 years that I can't figure out, because all of them have their instruction manual online, and Dr. White reads instruction manuals. And so, as one of your colleagues asked, for your test, you're going to need a calculator. You'll need it for test 1, 2, 3, 4, and the final. So get a good one. These are quite inexpensive. I think they're selling at, I don't get any kickbacks from these companies, I wish I did, from Walmart, Staples, and as a best friend of mine calls it, that French store, Target. But anyways, any questions on that? All right, let's go and do the problem set. Let me warn you about one thing. Even though I have my amplified speakers, and I tell you this in a classroom too, one of the hardest things for me to pick up, even with my speakers, is letters of the alphabet. So if you say, could I do 2B or not 2B, that's going, never mind. But if I do 5E, I might not hear the E well. And if I ask you to repeat it, that's my problem, not yours, but work with me on that just in case. Enunciate your letters well. All right, now the way we do the problems is I like to do one page at a time. I'll go through a couple. If you want me to go through a couple, ask. And if you look in, everybody see the practice problems on their screen? Thank you, thumbs up, people. I think part of the problem I was having with Zoom could have been the extra draw on that one port on my computer was messing my whole computer up, because I don't seem to be having as much problems with that either. I better shut up. But anyways, let's go through the first one. And this is a skill you should have. And that is write the following numbers in scientific notation. How do you do that? You move the decimal point, or where there would be a decimal point, to the right of the first non-zero number, integer. And here that's to the right of 6. Notice I put a little arrow there. And here you move, how many times do you move it? 1, 2, 3, 4, 5 times. You put the decimal there. If there's no decimal point at the end and the number is greater than 10, all zeros at the end are dropped. So this would be 6.52 times 10 to the 5th. And here we got a big number, and you count 3, 6, 9. Drop the zeros because this number is definitely bigger than 10. So that'd be 4.567 times 10 to the 9. Now, if the number is less than 0, lead zeros, first of all, you will always drop. And you don't have to, but Dr. White always puts a 0 to the right of the decimal. That's a good habit so I don't break. And you move the decimal to the right of the first non-zero integer or number, 1, 2, 3. And now if there were zeros at the end, and I should do one because I don't see an example here. But anyways, here you move it 3 times. When the number is less than 1, 10 to the x is a minus number. So that's why it's minus 3. This would be 5.67 times 10 to the minus 3. And here you move it 7 times. Nope, I don't have an example. So it's time for you to do one. Why don't you write that in scientific notation? Dr. White's going to be cruel today. I'm going to make you use your mind. That's 0.000920. While you're doing that, I need to check something. All right, I checked what I needed to check. Good news, I now know everybody who signed up for the course has been showing up. And don't forget, hand in today's lab today or by tomorrow at the latest, or you'll lose points. And let me do this. All right, everybody ready? Get set, go. You move the decimal point to the right of the first non-zero number, 1, 2, 3, 4, 9.2. Notice there's a 0 at the end, and I have a decimal, so I'm going to keep that. And I move that 1, 2, 3, 4. Since it's less than 10 or 1, that's the negative number, and that's how you do it. All right. Oh, let's do another one. These are fun. Why don't you write that number in scientific notation? And for those of you who can, not that I'm going to ever force you, but turn on your webcam so I can see all your pretty faces and Dr. White gets to know you a little. Next week, I'm going to be trying, I got to work it out yet, I haven't yet. I'm going to try an experiment we'll do in lab, and that is break you into small little groups and breakout rooms so you can meet your other students, and I'll go to the smaller breakout rooms and I get to meet you. And that way I'll get to know you. So a few of you already do, but this way, and also you can get to know some of your fellow students, which would happen in a lab, in a classroom, which unfortunately is not happening here. All right, let's do this. How do you write it in scientific notation? Move the decimal point to the right of the first non-zero integer, and that would be 7. I've moved it 2 times, and therefore, this is how you do it. This is not chemistry, but it's an important part of chemistry, knowing how to deal with numbers. And I have other examples. Now, number 2, if you've done it, all right. I will never ask that on a test. I didn't go through it in class because after I wrote this up in last semester, I realized, you know something, we never do that. You got a calculator that's always going to give you scientific notation. So why am I having students do that? So let's skip it. Dr. White lives in the real world, and I'm not going to make you do something just because it's in the book. You're not going to use it. Now, this is very important. How many significant figures are in the following numbers? How do you do that? All non-zero integers are significant. Zeros at the end of a number without a decimal are not significant. Zeros that are confined between non-zero numbers are significant. Zeros at the front of a number are never significant, and zeros at the end of a number with a decimal point are significant. So let's take a look at A. Well, 1, 2, 3, 4, 5. They're all non-zero, 5 significant figures. If we look at B, oh, a 0. It's at the end, no decimal, and therefore, guess what? 1, 2, 3 non-zero numbers, and you don't use that, so it's 3. And if we look at C, oh, look, there's a 0 again. And it's in between two numbers, non-zero numbers. Therefore, it is significant. And therefore, all these are in 3. Now, if we look at E, oh, when you have scientific notation, you do not count 10 to the minus or plus whatever for significant figures. You just use this like for a number alone, which is why this says 4 significant figures. But let's look at E. How many significant figures? Oh, zeros again, but they're in the front. Therefore, you don't count them, but non-zero numbers you do, 1, 2, 3, which is why 3. Oh. Now, if we look at F, oh, it's got zeros again. Now, the non-zero numbers you count, 1, 2, and then zeros at the end with a decimal point on either side are significant. So that would be 2 plus the 1, 2, 3 zeros, that's 5. All right, why don't you try this one? How many significant figures are in that number? I'm going to work you hard this morning. I should have brought my bullwhip. Actually, the bullwhip I have sort of died. I'm looking for a new one. I've had a number of them. Dr. White isn't unusual hobbies and weapons. I have bullwhip, nunchucks, boomerangs, and a few other things. No guns. I'm not into guns. They're too dangerous to have around. If I had a pair of nunchucks and I get mad at someone, they can run away. If I have a gun, nobody can outrun a bullet, which is why Dr. White doesn't own a gun, but things get real bad. Well, maybe I'll buy a shotgun. Hopefully I never will. All right, let's do this. Shut up, Dr. White. Okay. All right, how many significant figures? All non-zero, oh, I'm getting serious. All non-zero numbers are significant. 1, 2, 3. Oh, look, we have a 0 there. And it's at the end after a decimal point, so it's significant. So this has 4 significant figures. Your turn. How many significant figures does that number have? And if you notice, yesterday's lecture is already up on my YouTube channel as of last night. And for those who have your video, I try and zoom around so I can get everybody equal opportunity pass. For those of you who don't, well, hello. All right, let's do this. How many significant figures? Oh, here's the decimal. Zeros at the front are never significant. Non-zero numbers are. 0 at the end with a decimal point are. So that's 1, 2, 3. So that would be 3 significant figures. And that's how you do significant figures. Now, as you saw when I used a calculator, your calculator, in the term I like to use, can spit out some monster numbers. And if you put that down in the test, I'd mark it wrong. So you have to know how to round off. And you round off by, if you look at the number of significant figures you're going to keep, and then the one after that you use to round off. 4 or less, you drop it or replace it with zeros. And I'll talk about that when we go through some of these problems. If it's 5 or higher, you drop it or replace it with zeros, and the integer in front of that, you increase by 1. So if we look at this, round it off to 3 significant figures, keep the 1, keep the 1, keep the 5, that's our 5, oops, and then use the 5 to round off, that's 4, 5 or higher, drop that, increase the number in front by 1, you get 1.16. How do you do this one? Same thing. Now, here, round this off to 3 significant figures. It's got 4 because zeros at the end aren't, sorry about that, aren't significant. So I'll keep the 1, keep the 3, keep the 3, use the 8 to round off, by the way, use squiggly lines to show the round off number. And that's 5 or higher. I'm going to change that to 0 because this number is 10 or higher. The 1 in front I'll increase by 1. So it's 134,000. Now, the way to think of it is this number is between either 133,000 or 134,000. And what students sometimes misinterpret, you drop the zeros here and they put down 134. Well, if you have 133,800 marbles and you round it off, you just don't end up with 133 marbles. You missed a lot marbles. Oh, Dr. White just did a funny for himself. You don't want to be losing your marbles. Look out. It's totally worthless humor day. I got to remember that one. But anyways, so that's how you do it. And if we look at a number less than 0, round this off to 3 significant figures, F, keep the 5, keep the 8, keep the 7. We'll use the 3 to round off, that's 4 or less. Since it's past the decimal, you're going to drop the 3, drop the 0, and that's how you do it. And this is going to be mostly the type of stuff you're going to do on the calculators like this. So let me have you do a couple. And if we look at the following number, why don't you round that off to 3 significant figures? Like I said, I'm going to work you hard today. Not really. And when you're done, give me a thumbs up or smile. All right, I think everybody's done. I'll give you another 4.8 seconds. 4.2, 4.6, 4.67, 4.8. I have a funny watch. But anyways, let's take a look at this. Keep the 1, keep the 4, keep the 7. I'm going to use the 6 to round off. Is that 4 or less, 5 or higher? 5 or higher. Therefore, I'm going to drop this and this because I'm past the decimal point. And this number I'm going to increase by 1. And the correct answer is 4.8. All right, why don't you round this off instead of 3? Let's get out of my rut. Dr. White has a rut of 3 significant figures because the slide rule, which I used, we didn't have calculators when I was in college, I'm showing my age, was only good to 3 significant figures. But round this one off to 4 significant figures. All right, if you're done, give me a thumbs up or smile or do both. I think everybody's smiling. Oh, happy in chemistry. All right. How do you round it off to 4 significant figures? Keep the 4. I have a decimal point. Everything past that is significant. Keep the 3, I mean. Keep the 4. Keep the 0. Keep the 6. That's my 4. This is the next number is my round off. Is that 4 or yes? Less? Yes. Got ahead of myself there. And you drop that because we're past the decimal. And the correct answer, if you know, that's 4 significant figures. And that's how you do that. Is there a question? Hold on. Oh, a sword. Actually, I don't have swords, but I do have tactical knives. I'm a knife collector, both pocket and fixed blade. In fact, one of my best tactical knife, I actually had one of them custom made for me. That's back when I was working in the chemical industry and I was making 6-figure a year salary. The good old days. And these are good days too. All right. Well, look, I'm getting paid to have a fun time with a whole bunch of nice people. Such a deal. It is. All right, let's move on. And Anne's question is, what is the correct answer for? And I have a couple of mathematical operations. For math, when you do multiplication and division, you have the same number of significant figures in your answer as the number that you're multiplying or dividing by that has the lowest significant figures. I'll say it again. When you're doing multiplication and division, your answer has the same number of significant figures as the number you're multiplying or dividing that has the lowest number of significant figures. So if we look at A, 5.5 times 6.351, my calculator gives me this number. But if I look at 5.5, that's two significant, significant figures. SF is my shorthand for significant figures. 6.351 is 4, which is a smaller number. 2, so you have to round this off to 2 significant figures. Keep the 3, keep the 4. The round off number is 9. It's 5 or higher. I'm going to drop everything past the decimal, increase the 4 by 1, and that's the number you get. Now, I better point it out. I might have mentioned this once, twice, or 5 times. Dr. White doesn't walk on water unless it's frozen, and even then I stay off it. In other words, I make mistakes. And if we look here, this should be not 4, 5 significant figures, but it doesn't change the answer. Oops, don't look, Dr. White made a mistake. Anyways, 2, 5, how many significant figures should your answer have? 2, it's a multiplication. Therefore, you have to round this off to 2 significant figures. Keep the 2, keep the 1, use the 0, 4 or less. So I'm going to drop everything because I'm past the decimal, and that's 0.21. But if you see these numbers, and you saw it earlier when I did it, your calculator will give you those things. And on my test number 1, 2, 3, 4, and the final, underneath your name, it'll say, please use proper significant figures for all calculated answers. And if it's, say, a 5-point problem, and you put down the wrong number of significant figures, I will take off a point, even though the number was right. Say you put 0.2108064, and the round off is 0.21, I'll give you 4, not 5, and I'll let you know -1 for significant figures.
So does that change the answer for question E? Because you have 4 significant and it's actually 5. The first problem.
D,
7.5, letter E.
Yeah, I saw that too.
do I have a mistake there?
You said that for the
Yep,
first.
hold on,
year-
let me take a look at it. Give me time. Takes a while for my brain to work too. 1,
No
2, 3,
worries.
4, 5. That should be 5. So you're right. Oh no, I'm going home. Wait, I am home. Oh, look out, I'm in the zone, the humor zone. But anyways, you're right. That should be, whoever said that, thank you very much. How do I round this off to 5 significant? Keep the 6, keep the 2, keep the 7, keep the 1, use the 3, keep the 3, so that should be 6.2713. Well, I just lost a point. There goes my perfect score. Ouch. Thank you very much. Now, one of the things I didn't realize I did, but on G, I try and stay away from it, but it happened on the problem set. What I mean, stay away from it. When I write my own tests. I don't use test plan because I don't do multiple choice. And even then I write my own multiple choice, but I keep them to a minimum. Notice this would give you 2.323. Then if you had a calculator, it would be times 10 to the 0. 10 to the 0 is 1. So the number actually would be 2.3283. Then you'd round it off to 3 significant figures. So let me do this again, show you. If your calculation ever gives you, say, 10 to the 0, what does that really equal to? If you put down 10 to the 0, I'll never take that off on a test. And all of you have each other as witness, I said that. But in case you're wondering, 10 to the 0 is the number 1. And what I normally do is always do, because otherwise things like this happen, is I will actually calculate the final answers before I give you the test to make sure things like that happen. Also, when it comes to rounding off and things like that, I check the numbers. So it's not in what I call the gray area where even I'd have to think about it for a while. That's not fair to you. My tests are meant to be fair. Yes, you got to think, but I'm not going to try and go out of my way to trick you to get the wrong answer. That's not right. And I teach by my gold rule. What I didn't like done to me, I don't do to my students. And I had one instructor who played that way. That was the physics instructor. We got rid of him, but most of the class didn't do good because he was playing games on his tests.
Oh, Professor, I have a question on this.
One thing first, and I'm going to ask all of you, please call me Dr. White, not Professor, because
Okay.
unfortunately, over the last number of years, the term professor has, in my mind, been diluted. It's no longer someone with a PhD, be anybody who's been at a school long enough, but that's my personal preference. Nothing wrong with what you said, but this is a favorite, Dr. White. Go ahead with your question.
Alrighty. So, you said that you get to the 0. I'm pretty confused because it's 10 to the 4th and 10 to the 3rd. Would that be 10 to the 1st?
Yeah, but look at this number, 1.22 divided by 5.25. That would be a number less than 1 times
Okay.
10 to the 1st would give you this number.
Ah, okay.
That's a good observation. Thank you for asking, because now you know. And if you want, try that on your calculator.
Okay.
I know what
Thank
you did.
you.
You know how to do in your mind 10 to the 4 divided by 10 to the 3. You subtract 2 numbers. But the first number, 1.22 divided by 0.21 would be less than 1, and you multiply times 10 would give you the 2.3238.
Thank you.
You're welcome, and thank you. All right. I'm going to go a minute or two past our break time. We're still going to get out of here early. Don't tell anybody I said that. And let's look at addition. And addition, you have the same number of significant figures past the decimal as the number you're adding that has the smallest significant figures past the decimal. So if we look at, and you don't ever round off stuff to the left of the decimal, you keep it. So if we look at B, these two numbers we're adding up, we get this number, and notice we have 0.336, that's 3 past the decimal. On the second one, 0.58, that's 2 past the decimal. Therefore, we have to round this off to the what's lower, 2 or 3. Hopefully you pick 2. That's 1, 2 past the decimal. Use the 6 to round off. As 5 or higher, it's past the decimal. I'll drop it and increase the number in front 1 to 2. And that's how you do it. Let's have you do one. Why don't you try adding these two numbers? And while you're doing that, it's time for a quick Dr. White story. My mother was an accountant, and by the time we were 7 or 8, she expected us to know how to add and subtract real well. And back then, Marshall Field's, which is now Macy's, if you went and bought something, the clerk added up your different things on a slip. They didn't have machines now that do it, or the cash registers that do it automatically. And my mother expected us by the time we were 8 or 9 to, when we went with her, to watch the clerk, and that would be upside down to us, and add it up, make sure they didn't make a mistake, which they did. Not on purpose, but sometimes they did. Now you have a Dr. White story. All right, let's do it. Hopefully I did my math correctly. Here's the number your calculator would give you, or you just add it up. But notice this has how many significant figures past the decimal? 1, 2, 3. This has 1, 2. And which is the lower number? Hopefully all pick 2. And therefore, this should have 2. We keep the 1, 1, 0, 1 that you don't play with, you keep. And then how do you round this number off to 2 past the decimal? Keep the 8, keep the 3. This is my round off. That's 4 or less. I'll drop it. And that's how you do it. Let's do one more. Your turn. Boy, time flies when you're having fun with significant figures. Not. Maybe. I see someone with their hand. Question?
After the break, are we going to be doing the Beyond Lab Z thing?
Yes, we are. What I'm going to do is I'll be going through, and thank you for your question. All questions are good questions. Thank you. After the break, we'll go through Beyond Lab Z, an actual lab you'll do. I'm going to show you the basic stuff. If I'm guessing correctly, that should take somewhere 30 minutes or less. So we're supposed to go till 11:50. No, we're getting out early. And the real lab, if we were at COD, my labs get out early because I teach people how to do it and they get it done quickly. Some instructors, you wonder what they don't teach the students how to do the lab, and they need the whole lab period to figure out what the heck am I supposed to do, which is not right, at least in my mind. All right, let's do this. If we come here, this will be 3.1000, but this is 1 past the decimal. This is 1, 2, 3, 4. Remember, all zeros are significant past the decimal. What's the smaller number? Hope you all pick 1. So the correct answer is 3.1. And why don't we take a quicker break so I can let you get out earlier? You can smile if you want or not. And I'll see you at 10 o'clock. I'll do a quick stretching. See you in a couple minutes. All right, ring, 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 ring. Let's get going. Everybody back? Wait for everybody to get on. By the way, did I tell you I'm ambidextrous? I can do it this way or this. All right, time out for something, a Dr. White challenge. When I was young, my father used to always tell me a smart person is never bored, and he'd challenge me with things. Can you do this? This goes forward, this goes backwards, and do them at the same time. Don't try this while you're driving a car, doing heavy machinery. When you master that, do it with your thumbs. This goes backward, the other one goes forward. And when you do that, learn how to wiggle your ears, especially you can do either one. There's muscles back there. It took me about 3 months when I was about 7 to figure out my father can do it. I better be able to do it. And there are muscles back here once you find you can move them, just like these. Let's get back to real chemistry. Well, that is chemistry in a way. All right, let's go through Lab Z. Before I do that, remember you should be handing in uploading today or latest tomorrow, but really today, last week's safety lab. And please do it. It's 10 easy points. Labs, the way I grade it, are pretty easy to get good scores. They're not hard to do, and do them. You don't want to lose easy points. I had a student last semester, he lost a whole letter grade because he didn't hand in enough labs. He lost about 40 points. He should have gotten an A, he just barely got a B, and there's no reason not to. So that's why I'm going to be pestering you and in the lab. All right, let's look at Beyond Lab Z. Everybody see Beyond Lab Z on your screen? Thumbs up, people. Thank you. All right, I've logged in already. You need to download if you haven't, and you don't have to do it now, but in order to do the lab, you do the chemistry and the physical science modules. I'm going to connect. And notice you have chemistry, I put them all in. And physical science, you're going to click on physical science, higher ed, high school one. And does everybody see the density, optics, and circuits? All right, you'll click on density. And you hear the weird noises. And everybody see the graduated cylinders on there? Good. All right, this is the lab you'll be doing for density. Let's look at the actual lab. Everybody see the density lab from Dr. White? Thank you, thumbs up person. This is, you can download from Blackboard. And density. Density is an important physical property. Oh, you learned about physical properties, and it's an important one. Density by definition is weight per volume, or sometimes you'll hear Dr. Whiteby say weight per unit volume. And to determine the density of an item, you need to measure its weight and determine its volume, and then use Formula 1 to calculate the density. By the way, use proper significant figures for this, any calculation. Now, here's something important that you may not have learned, and that is an important aspect of density is lower density substances float in higher density liquids. And same thing, higher density liquids, whether or solids, will float in, or lower density solids or liquids will float in higher density liquids, and higher density substances will sink in lower density liquids. If you don't believe me, if you happen to have a cannonball and a feather at home, I don't, but you might, if you take a big heavy weight like lead or iron, a ball, like a cannonball, and you have a big barrel of water, if you take the cannonball, let it go, guess what? It sinks. Why? Because if it's lead, that's higher density than water. Now, if you take a little feather and you put it under water, and no, I'm not going to put a feather in my water bottle, but anyways, I don't even have any feathers. No birds in my house either. But anyways, oh, that was awful. It will float because the density of a feather is much less than water. So things that are lighter float on things that are heavier. Things that are heavier sink in liquids that are lighter. And that's an important part of density. Now, when I wrote this, we didn't have Beyond Lab Z. And if you want to see how to do a liquid, we're doing it a little differently, and I'll show you how. Here's a YouTube to watch for a solid. You use water displacement. You weigh the solid, put water in a graduated cylinder, which is like a measuring cup like we use in a lab. And then you put the solid in there and the water will rise. And the difference from the initial and final volume is the volume of that solid. And when we do this lab at COD, we actually use a rubber stopper that has a hole in it. So you can't measure to do the volume, you have to do the displacement. Now you'll be using the Beyond Lab Z. Hold on one second. This way you won't see the little red lines and other corrections. When my software doesn't like chemistry names, you'll use Beyond Lab Z Density Lab in the physical science choice. Now, Dr. White has written procedures for chemical plants that if I don't do it right, a couple $100,000 in chemicals are just gone down the drain. And B, if I don't do it right, people could die. That's never happened. And I use that skill to write my labs. Now, here's the procedure. Now, if you want a basic understanding of things you'll be doing, look at the PDF file 345 that's attached to Density Lab in the assignment area for you to download in Blackboard. And also what you're seeing here. Part 1, you're going to be doing density of a liquid. I'm going to go through this part and then I'll show you how to actually do it in Beyond Lab Z. You're going to, for each of the liquids in table 1, you'll follow the following procedure. You open the density lab. If the balance is off, turn it on. Place the empty beaker on the balance and tare it. Tare it is what we call zeroing it. Push the tare button. Now here I have put it back on the balance this morning when I was practicing again. I found out you didn't have to do that. And I'll show you when we do the lab. Then pick the liquid from the dispenser in the upper left-hand corner of the screen using the up and down arrows. And I'll show you this in a second. Dispense the full amount, not half. Originally, I thought half because if you put something else in there, it would overflow. They're actually not truly full. So this, it's easier to read when you do the full amount into the graduated cylinder. Then you'll record the volume, and I'll show you how to do that when we're through with this part. Pour the contents of the graduated cylinder into the beaker and weigh the beaker and record that weight. Then pour the contents back into the beaker and then use the blue handle to flush everything. And you can do the next. You'll do steps 3 through 9 again for all the liquids in table 1 you're supposed to do. And then you calculate the density by this formula, which I gave you earlier, weight divided by volume. Now here's table 1. You'll have to do the alcohol, the corn syrup, mercury. Now, to make it interesting, Beyond Lab Z has some unknowns, which they call virtual fluid, or later on you'll see virtual solid. And if your last name begins with A through L, you do virtual fluid A. If your last name begins with M through Z, you only have to do virtual fluid D. Now, I found out a day or so ago, when we do this lab with unknowns, they're actual unknowns. Well, it turns out the Lab Z people just made up some numbers. So Dr. White made up some names. And let's go through this, how to do this in Beyond Lab Z. All right, everybody see the graduated cylinders again? Thank you. All right, now, the first thing we'll do is I'm going to just make sure this is tiered. Notice it's 0, 0, 0. Take your cursor, put it on there. You're going to want to record this, write it down. And then what liquid do I want? And here you use the up and down. I want alcohol. And it makes, you see the alcohol on there. Hopefully the alcohol I use is clearer than that. But anyways, click on the fill button. Notice see how it's half and full? You want full. And it's full. And then right over here, if you put your cursor right here, you'll see zoom. You got to do it above the liquid. And you'll see here. Now, this is a graduated cylinder. It's a big one. I've already told them they should use 100, not 250s. Each line right here corresponds to 2 milliliters. This longer line is 230. This would be 232, 234, so on, 240, 250. Now, notice your one line, small line below 238. And if we were in the lab, you could actually see better, but this would be 228. So the volume you'd write down is 228. Now you need for a liquid to find the weight of this liquid and pick it up. And I have trouble finding the port. There you go. Did I not tear it? Hold on. I thought I did. Well, now it's teared. And the weight of that liquid was 179.263 grams. Use all those numbers and it'll bounce around. And in real life, this bounces around too. Let's call it 179.261. And just pick this last number. This is the round off. Remember about significant figures. So you take the weight divided by the volume, and that will give you the density. Let's try something. I've never done it. Nope, that doesn't work it. Now, to do the next one, pour this back in. And then flush it. Dr. White thinks that's funny. And then you'll do the next one. And that's how you do liquids. And you'll fill the chart here, the weight, the volume, and you'll calculate the density using this formula. Now, let's look at solids. You'll do each of the solids in table 2. I'm assuming everybody can see my lab right now. Can you see it on the screen? Thank you. And if you haven't, say you took a break, you open it up, density lab, turn the balance on. If it's not, tear it. Take a solid from the upper right-hand screen. I'll show you this in a second. Put it on the balance and record the weight in table 2 and fill the graduated cylinder with water. Record the volume, and that's the initial volume. Then take the solid from the balance, put it in the graduated cylinder, push the drop button, and record the final volume. use the blue lever to empty it, and then repeat steps. Oh, I forgot to write this in. Should be 3 through 9. And record it in there. And you calculate the densities for the solids in table 2 by using the formula. The density of the solid equals the weight of the solid divided by the number that you get, final volume minus initial. And by the way, density is, we're using grams per milliliter for this lab. And here are the one, ooh, I'm gonna let you use gold. And here we have weight, initial, final volume, and you'll measure the density, determine it using this formula. And once again, I have unknowns. If your last name is A through L, you'll use virtual solid B. If your last name begins with M through Z, you use virtual solid C. If you want to do both, you can, but you don't have to. And then for here, you have to determine the identity of the solids, virtual liquid and the virtual solid. I'm going to go through this in a second. Let's do the density of a solid. Now, everybody see the lab now with the graduated cylinders? Thank you. All right, up here in the upper center, I guess, you have the different solids you're going to be using. It's sorted in alphabetical A, B, C, then starts here. I found a mistake. Here's sodium, here's silver. They should be switched. I'll tell it. And then these last 4 on your bottom are your unknowns. Now, let's do one. And how do you do that? I'm going to take my beaker off. I'm going to tear it. And let's see, what did I have you do? Hold on one second. Let's do platinum. Notice how I use my cursor to carry it over to the balance, and you record the weight. Next, I'm going to go find water. I'm going to fill the graduated cylinder. Notice I got it to water. I have it on full, hit fill. Now, you don't have to move this over, I found out. I thought you did, but move the ball, let it go, and you'll see right here in green it says drop. But before you do that, you should record the graduated cylinder. Notice each one of these lines is 2 milliliters. The liquid here, and there, I've complained already, this should be better, but this is 230. Each one of these lines is 2 milliliters. So that would be 228. This is 226. Record the initial volume. Next, and I record the weight. I'll put this over here. I'll hit drop. Oh, look, it's saying this is how many seconds it took to drop. I don't know. I guess if you're measuring which is more viscous, but we don't do that in this lab. And now the new volume, remember, this is halfway between 230 and 250. That's 240, 242, 244, 246, and 248. You could even say that's almost 247, halfway between here and here. I could even say 246.5, but we call it 247. And therefore, that would be your final volume. Again, weigh it, fill it with water, measure the volume initially, put the ball in there, and then drop it, measure the new volume, and you're done with that sample. And now, originally I thought you had to push this back. You don't. All you gotta do is flush it, and now you're ready for the next one. And just to show you, if you want to do on your own, I don't have it in the lab. If you click on the clipboard over here, you have some things. And let's look at steel and mercury and water. And notice I have mercury in here, water in here. Mercury has a heavier density than water. Steel, if I drop it, oh, it floats to mercury. So steel has a lower density. And if I have steel and water, oh, look, it fell. So steel has a greater density than water. And you'll do the same thing. Again, the unknowns are over here for the virtual solids. Now, one thing, if you want to have a lot of fun, I'll teach you later on that sodium and water gives off an explosion. You don't want to. This is sodium. Everybody watching? 3, 2, 1, drop. Don't try that at home, please. Now you'll do the densities just like I showed you for the solids. And now you have a virtual solid and a liquid. Put your letter designation, like say, if your last name was A through L, you'd use virtual solid B, and you put down B, what's your identity, and now what's the density that you calculate from this formula right here for the solid. And then you'll find the identity. How? Well, here's the identity, substances, some common substances. Unfortunately, Dr. White had to make up some names because they use fake numbers for their A, B, and C, and maybe not. An example would be Polaroid. For those who don't know Flash Gordon, look up Polaroid. And then you'll have these questions to answer. And things like determine which of the following will either sink or float when put in a large bucket of liquid lead. And by the way, if you need to know the density of things, they're up above. Or you can look on the internet. And that's how you do it. And this will be due next Thursday. So any questions? Let's go to this. Any questions? All right, with that, I said I'd get you out of here by 10:30, and I did. If you have any problems with Beyond Lab Z, come to my office hours on Monday or Wednesday night, and I'll be able to open it up and we can work through it. So you shouldn't have any problems. And with that, I'm going to tell you a couple of, first of all, public service things. If you don't know, later today it's going to get real messy out there. We're going to have rain, sleet, snow, and then tonight and tomorrow and the next days, it's going to get brutally cold. Make sure you have a full tank of gas in case of emergencies. And 2, make sure you have a lot of food in your house in case you got stuck in your house. Because when I was younger, the great snowstorm of '67, we were stuck in our house for a couple of days. It was that bad. My parents luckily had always kept a lot of food in the house. We were safe. In '79, there was a great snowstorm that hit Chicago. I lived in an apartment in Chicago. And luckily, I knew to keep a lot of food in my house. And we were stuck in our apartment for a couple of days, and everybody was in the city. And I don't know if that will happen today, but stock up always for the winters you should. And with that, stay warm, stay safe, Gein gesund, be healthy. I'll see you on Monday. Have a nice rest of the weekend.
Thank you.